Good morning, children. Most of you are coming to school, amma. Complete your classworks, projects, activities. So, chemical bond, electromagnetism, carbon and its compounds are deleted from the portion. So, children, here in this lesson we are going to discuss relation between electricity and magnets. Electromagnetism. If we see electric appliances like TV, computers, watches, calculators, there is a relation between magnets and electricity. Electromagnetism. How we got that relation, how it deflects, what are the instruments, appliances, works on electromagnetism, everything we are going to learn in this lesson. That is AC generators, motors, transistors, diodes, everything you are going to learn. Actually, the complete electromagnetism which it is there in the old syllabus, it is a good. By reading that you can understand what a diode, transistor, how chip is made, everything. Few topics are deleted, amma, and in this 10th standard, in this pandemic situation, complete electromagnetism is deleted. Now let us read the first introduction paragraph. In previous chapter on electricity, you have learned that about the heating effects of electric current. We may use electric appliances in our day-to-day life, such as electric motor, generators, calling bells, electric cranes, etc. How do they work? How do electromagnets work? Is there any relation between electricity and magnetism? How can we produce magnetism from electricity? So here in this chapter you are going to learn relation between electricity and magnetism. Ostrad is a scientist. He gave the first relation between electricity and magnetism. How he gave that relation? Let us discuss with a simple activity 1. Ostrad experiment. Take a thermocol sheet and fix 2 wooden sticks on it with 1 centimeter length and have a small slit on it. Arrange the copper wire of 24 gauge so that it passes through the slit and make a circuit. The circuit consisting of 3 or 4 voltage, key and copper wire which are connected in series. Now keep a magnetic compass below the wire. Bring a bar magnet close to the compass. Does the needle get deflected by the bar magnet or not? Why does the needle get deflected by the magnet? Take the bar magnet far away from the circuit and switch on the circuit. Look for the changes in the position of the needle. What do you notice? Is there any change in the position of the magnetic needle? So what is the experiment? Take a thermocol sheet and of what we say a wooden stick of 1 centimeter, 1 meter length and have a slit on it. Both the wooden sticks are arranged on a thermocol slit, and through that slit pass a copper wire whose capacity is 24 gauge and is connected to 3 volts or a 9 volts battery. Consists of a 3 or 9 volt battery. Just you can see in the diagram figure 1, beneath that we have one magnetic compass. When a current is passed, we can see the reflection in a magnetism. This shows that there is a relation between electricity and magnetism. There is a relation between electricity and magnetism. Okay. When we switch off that, it shows a deflection, magnetic needle. When it is switch on, it shows a deflection. When switch off, again it comes to rest. It means by passing the current, we can see the deflection in a magnetic compass. Needle of that magnetic compass deflects. So there is a relation between magnetism and electricity. So electromagnetism. And what is a magnetic field? Just take a, suppose it is a bar magnet and it is an iron nail. If I bring close to this, it attracts. Just here it attracts. If I move here, it attracts. If I move here, it does not attract. It means up to this extent, around this, it is showing its magnetic power. Such is said to be a magnetic field. The area or the field or a line where magnetic power is shown and influenced, such field is said to be a magnetic field. Okay. Now comes to the lines of a magnetic field. What is meant by lines of a magnetic field? How can you find the strength of field at a bar in the direction of field? Put two discs on the either side of the compass. Take a needle out of now. You by seeing that you can understand. Place a bar magnet at the take a white chart, place on the table, and take a bar magnet, place on the table, and take two magnetic disc or a magnetic substance. Just you place near that. It deflects. First is a position. See the figure 2. You can see the curve positions 1, 2, 3, 4, 5. The first curve, it is near that point, it is deflecting. Then just move certain distance. Again it deflecting. Move certain distance, deflecting. So if we join, it gives the curves. Either sides, that side and this sides of the bar magnet. Here also you can check. Suppose this is a bar magnet. This side, if you are placing the bar or disc, it is deflecting. Here it is deflecting. Here it is deflecting. Just you make a curve. Again a curve to that point. So if we join all the lines, it gives this figure. This shows that magnet, it shows its power in the form of a lines. It is said to be a magnetic lines. Magnetic lines. And next comes to the field is finished. Magnetic flux. If a line or a flux, if it is passed in a particular area, then it is said to be a magnetic flux. Consider a uniform magnetic field in a space. Imagine a plane of certain area A placed between the field as shown in the figure 3a. You notice that new field lines pass through the plane. This number gives an estimation of the field strength. The number of lines passing through the plane of an area A perpendicular to the field is called magnetic flux, and it is said to be the pi. The number of lines passing through that particular area is said to be is perpendicular to the field is said to be a magnetic flux and denoted with the letter pi. And magnetic flux density. What is meant by magnetic flux density? It gives a strength of the field is technically called magnetic flux density. Magnetic flux density is defined that magnetic flux passing through the unit area perpendicular to the field is known as magnetic flux induction, magnetic flux density. It is denoted with the letter B. Pi is magnetic flux. What is a magnetic flux? Number of lines, magnetic lines passing in a unit area. And magnetic flux density, number of lines passing through unit area perpendicular to the field is known as magnetic flux density. See children, in this lesson we are going to discuss the relation between electricity and magnetism. Electricity and magnetism. Electromagnetism. So first Einstein, what he did, he took a thermocol sheet and he arranged two wooden sticks on it with a slit. Just pass a copper wire. By passing the copper wire, and the both ends of the copper wires are connected to the 9 volts or a 3 volts battery. Beneath this, you place a magnetic compass. When a current passes, we can see the deflection in the magnetic compass. It means the electricity is producing the magnetic field which makes our magnetic needle to deflect. This is the electromagnetism. And the area of the field which shows its influence is called magnetic field. And the number of magnetic lines passed in a unit area is said to be magnetic flux. And the number of lines in unit area perpendicular to the area is said to be magnetic flux density. Magnetic flux density is denoted with the letter B. B is equals to pi by A. What is pi? Magnetic flux. Magnetic flux is nothing but magnetic lines of force passing in unit area. That is perpendicular to the magnetic field is said to be a magnetic flux density, and that is denoted with the letter B. B is equals to pi by A, or pi is equals to B by A. B into A. Okay. What are the units of magnetic flux density? Weber or meter square. Weber by meter square is the unit of magnetic flux density, are also known as Tesla. It is also known as a Tesla. Okay. Now comes to the magnetic field due to currents. How magnetic field is produced when a current is passed in different positions. First position is magnetic field due to straight wire carrying current. Here a long electric wire or a pole is taken, just retort stand. To the stand wind the copper wire, and it is placed on a wooden plank. Two ends of the copper wires are connected to 9 holes battery. 9-hole battery, and around that now you can place, around the copper wire you can place magnetic compass. Magnetic compass. What happens when a current passes? We can show there is a deflection in a magnetic needle. It means when magnetic needle deflects, if it is placed in a magnetic field, magnetic compass needle deflects. Here also, passing the current through the straight current carrying wire, the wire should be a straight, so it is said to be a straight wire carrying current. Then how will be the current around that? Do the direction of the, how will be the correct direction? What is the shape of the magnetic field around the wire? It must be circular. What is the shape? It must be circular line. So we conclude that magnetic lines are called closed lines. The magnetic lines due to straight wire carrying current is shown in the 4B and 4C. This can be verified by sprinkling iron fillings around it. What is the direction of magnetic field induction at any point on the field line? In the current flow is vertically upwards, outward, out of the page. If the current is flowing upwards, then it is said to be out of the page. The field lines are in an anti-clockwise direction. The current flows into the page in downwards direction, the field lines in a clockwise direction. So underline, now it is not important, but every time we used to ask how will be the current, how will be the magnetic field in straight wire carrying current. In straight wire carrying the current, how will be the magnetic field? In circular shape. And when a current flows vertically upwards, that is said to be out of the page, the field lines are in a clockwise direction, anti-clockwise direction. If a current flows into the page, that is inward direction, then the field lines are in out of the inside the page. Okay, in a clockwise direction, that it is an anti-clockwise direction. And which rule it determines? If we are carrying the current carrying wire with your right hand thumb in such a way that thumb is in the direction of current, then the cold figure shows the direction of magnetic field. Suppose straight carrying wire is held in my hand. Just I am holding in my right hand in a straight line. This thumb indicates the direction of the current. The remaining 4 fingers which I am curling, that indicates the magnetic field. So around the electricity there will be the magnetic field. This is about the right hand thumb rule. And how will be the current direction? How will be the circular shape of that current? When it passing through straight carrying wire, it will be in the circular shape. And in a vertically upwards out of the page, it is the current direction is in a anti-clockwise direction. If the current flows into the page in downwards, the magnetic lines are in a clockwise direction. Clear? Magnetic field due to circular coil. What coil they are using? Circular coil. For that we need to take a thin wooden plank, make a 2 holes to the wooden plank, insert a copper wire through that holes such that it makes a coil circle, and 2 ends of that wires are connected to the 9 holes battery. Now see the figure 5a, all of you children. It is a wooden plank, 2 holes, through that holes we are passing the copper wire, and 2 ends of the copper wires are connected to the battery. Beneath that they place the magnetic compass. When a current passes, we can see the deflection in the magnetic compass. Magnetic compass. And do the same for other point taken below. Draw the corresponding lines. Can you tell the direction of magnetic field on the coil? This could be the answer from the connection of the orientation of the magnetic needle. You can observe when a compass needle is kept in the center of the coil. The direction in which compass needle come to rest indicates the direction of the magnetic field. Okay. Which rule is applied here, children? When the current in the coil is in clockwise direction, the direction of magnetic field is due to current coil points away from you. The direction of field due to coil or a solenoid is determined using right hand rule. Right hand rule. When you curl your right hand fingers in different direction of current, the thumb gives the direction of magnetic field. Thumb gives the direction of magnetic field. So this topic is complete deleted. Those who are not coming, children, I am just in the class itself daily, those who are coming, I am revising. 15 minutes lesson is going and revising, because the covered syllabus is finished. Whatever the lessons I taught is there in the syllabus. So my portion is finished. Just deleted topics I am telling, and revision also I am doing in the class. So those who are not coming, children, please watch the videos and go for the revision. I took the topics as is, bases and salts. Read all the answers related to pH. pH in digestive system, pH in aquatic life, pH in growth decay, pH in finding the nature of the soil, pH by self-defense. And 2 blanks, calcium phosphate and 2 sulfate and 2 molecules of water is known as gypsum. CaSO4, 2 molecules of water is known as gypsum. CaSO4, half molecule of water is said to be plaster of Paris. Plaster of Paris. And now you will find what is pH. pH is used to find the strength of acids and bases, like a universal indicator. It is called universal indicator. And pH papers also, scales and papers are available. By seeing the different colors, we can find the pH strength. That is, if it is less than 3, 5, 4, it is said to be a strong acid. More than that, it is said to be a weak acid. And 7 is a neutral. Less than 8, 9, 10, 11, they are the weak bases. Up 12, 13, 14, they are the strong base. pH shows the concentration of H plus ions and more H plus ions and concentration of OH minus ions. pH in tooth decay, pH in aquatic life, pH in soil, pH in digestive system, pH by self-defense. All these are important. Okay, children? Thank you, ma.